Okay, in this video we're going to talk about solving equations that are not quadratic. So in the last video we saw 5 different quadratic techniques. We're going to see a few non-quadratic equations in this one. The first of which is going to be rational equations, and if we think about what that's going to mean, the word rational, we should think rational numbers. Rational numbers are those that can be written as a fraction. So rational equations are going to have fractions, and the fractions are going to have variables in your denominator. So if we have something like x over 2, that's not really a rational equation because we can just write that as 1/2 x. But if we have a variable in our denominator, that's going to make it a rational equation. In order to solve the rational equations, we must multiply everything. So all terms by all factors in all denominators. So we're going to need to factor every denominator and then multiply each term by each factor in every denominator. What that's going to do is it's going to allow us to cancel out all the denominators, and it's going to leave us with generally either a linear or a quadratic equation. But because we have denominators, we're going to need to check for extraneous solutions. And those are the solutions that we get sometimes, even if we do the work correctly, that don't actually work in our original problem. So let's go ahead and take a look at an example of a rational equation. So we need to solve 1 over x minus 2 equals 3 over x plus 2 minus 6x over x squared minus 4. So the first thing we wanted to do is we want to look at the factors of each denominator. So we have an x minus 2, we have an x plus 2, and if we factor x squared minus 4, we're going to get an x minus 2 and an x plus 2. So really the only factors we have are x minus 2 and x plus 2. So what we want to do in this problem is multiply all 3 of these terms by both x minus 2 and x plus 2. So again, multiplying everything by those 2 terms that we had in denominators. So what that is going to allow us to do is in this first one, we have an x minus 2 in the denominator and x minus 2 in the numerator. We can cancel those out. We have an x plus 2 and x plus 2. We can cancel those out. If you were to factor x squared minus 4, again, we'd get x plus 2, x minus 2. So both of those are going to cancel. So when we simplify this, all we're going to have left is x plus 2 times 1 equals x minus 2 times 3. Minus, those are all gone, and all we have left is 6x. So if we distribute the 1, we really don't have to distribute a 1, but distribute the 3. And then we can just kind of solve from there. And we get x equals negative 2. But again, we have to check, make sure that the answer is going to work. So if we take x minus 2 and we plug it in here and here, we're going to get a 0 in the denominator, which we can't have. So that's actually one of those extraneous solutions. So we're going to say that this has no solution. So again, what we want to do on those is we want to find every factor in the denominator, multiply everything out, check our answers. The next type of equation that we can have is a radical equation. Shocking, those are ones that contain radicals. So one thing we wanted to not forget is that rational exponents, and there's that word rational again, so fractional exponents are also radicals. So if we have something like n to the 1/2 power, that's really the same thing as the square root of n. In order to solve radical equations, what we want to do is isolate our radical. So that means, get our radical by itself on one side. And then we want to raise each side to the reciprocal power. So if we think about the square root, its power is 2. The square root's power is 1/2. The reciprocal would be 2, so in order to get rid of the square root, we have to square it. And then, last but not least, we want to check for extraneous solutions. So, jumping in, let's take a look at a problem. Solve square root of 2x minus 5 minus square root of x minus 3 equals 1. Now, this kind of is a little bit different than what we just saw a second ago. We wanted to say isolate the radical, but in this case we have two radicals. So if you have two radicals, you want to move one to one side. So we want to basically split the radicals if there are more than one. So we're going to move that square root of x minus 3 to the other side. And now we want to get rid of this radical, so we want to square each side. So a square root squared is just going to give us the radicand. Now don't make the mistake and just square this and square this. We need to remember that squaring is really just multiplying by itself. So we need to use our distributive property here. So radical x minus 3 times radical x minus 3 is going to be x minus 3. Radical x minus 3 times 1 and 1 times radical x minus 3 is going to give us 2 radical x minus 3's. And then 1 times 1 is going to give us 1. So x minus 2 plus 2 radical x minus 3. So now we're really looking at a single radical equation. So we want to get this radical by itself. So let's subtract the x, let's add the 2. So x minus 3 is equal to 2 times the square root of x minus 3. Now we have the square root isolated. You could, if you want, divide by 2 here, but that's going to make the squaring a little bit more ugly. So we're just going to square it the way it is. X squared minus 6x plus 9. Again, make sure you're using your distributive property. Distribute your 4. And move everything to one side. So we get x squared minus 10x plus 21, and this is now just a quadratic that we can factor. So we're going to say x minus 7, x minus 3 equals 0, so then x is going to equal 7 and x is going to equal 3. You can plug them in, they're both going to work. So let's move on to the next one. Just another kind of look at this, we have x minus 4 to the 2/3 power equals 25. So this is a radical. If you wanted to write it as a radical, the 3 is the radical, the 2 is a power. So you could write it like this, or you can write it like this. But I think it's easier just to keep it as a 2/3, because to get rid of a 2/3 power, all we have to do is raise it to a 3/2 power, right? Multiply or raise each side to the reciprocal power. So that's going to give us an x minus 4 on this side and a 25 to the 3/2 power on this side. We need to go ahead and simplify this a little bit. So if we think 25 to the 3/2, we can think of that as the square root of 25 to the third power. So the square root of 25 is plus or minus 5 to the third power. So x minus 4 equals plus or minus 125, because a negative times a negative times a negative still gives us that option to have a negative here. So x is going to equal 4 plus or minus 125. And again, in the interest of time, I'm going to leave that up to you. You can surely add 125 and subtract 125 and check your answers to make sure they both work. The last type of problem that we might come across for now is going to be absolute value equations. And again, mind-blowing here, but absolute value equations are equations that contain absolute values. Now, if we're going to solve absolute value equations, what we're going to need to do is isolate the absolute value, and make two equations. The first equation is going to be the subject equal to, we're going to call it the answer, but it's not really the answer. And then the second one is going to be the opposite of the subject. Equal to, again, we'll call it the answer, but it's not really the answer. And then we're going to solve those, and we need to check solutions for extraneous. Now, one thing that we do need to keep in mind is absolute values can never be negative. So when you isolate this absolute value, if you have absolute value of some stuff equals a negative number, you can go ahead and say no solution, because absolute values are never going to be negative. All right, so let's run through this example real quick. We can see that the absolute value is already isolated, so our two equations, we want to take the subject, which is x squared minus 3x, set it equal to the answer. So what I meant by the answer is what's on the right-hand side, so in this case, negative 4x plus 6. Then for the other one, we want to take the opposite of the answer and set it equal, the opposite of the subject, and set it equal to the answer. And then from here, it's just solving. So x squared plus x minus 6 equals 0. We have to do a little bit more work here because we have some distributing to do. You could move this stuff to the left. I'm going to move this stuff to the right so we can have a positive leading coefficient. So x squared minus 7x plus 6 equals 0. And then it's just a matter of factoring and solving. Check your work. You're going to get two answers from this equation, two answers from this equation. And of the four possible solutions, two of them do not work. So it's up to you. Finish this problem and check all four solutions. And then we will call it quits on this video, and we'll see you in the next one.